This is the Codeforces problem 580C, Kefa and Park. Kefa decided to celebrate his first big salary by going to the restaurant. He lives by an unusual park. The park is a rooted tree consisting of n vertices with root at vertex 1. Vertex 1 also contains Kefa's house. Unfortunately for our hero, the park also contains cats. Kefa has already found out what are the vertices with cats in them. The leaf vertices of the park contain restaurants. Kefa wants to go to a restaurant where he will go, but Kefa wants to choose a restaurant where he will go, but unfortunately he's very afraid of cats. So there is no way he'll go to the restaurant if the path from the restaurant to his house contains more than m consecutive vertices with cats. Your task is to help count the number of restaurants where Kefa can go. So time limit is 2 seconds and memory limit is 256 megabytes. And the input and output are standard input and output. So for our input, we have two integers n and m, the number of trees, and a maximum number of consecutive vertices with cats. That is still okay for Kefa. The second line contains n integers a1, a2, all the way to an, where each ai either equals 0, the vertex I has no cat, or 1, the vertex I has a cat. The next n minus 1 lines contain the edges of the tree, and it's in the format xi, yi, where xi and yi are vertices of the tree guaranteed by the edge. It is guaranteed that the given set of edges specifies a tree, and the output is a single integer, the number of distinct leaves of a tree path to which from Kefa's home contains at most m consecutive vertices with cats. So let's take a look at this first example. Let's remind you that a tree is a connected graph on n vertices and n minus 1 edges. A rooted tree is a tree with a special vertex called a root. In a rooted tree, among any two vertices connected by an edge, one vertex is a parent, the one closer to the root, and the other one is a child. A vertex is called a leaf if it has no children. So in this first example that we have right here, there is nodes 1, 2, 3, and 4, and nodes 2, 3, and 4 are leaves because they have no children. Now, 1 and 2 have cats, as we can see, because they are red, and so then we do not go to 2 because from the path from 1 to 2, there are 2 cats, and as per the input, you can only have at most 1 cat. So m is going to be greater than or equal to 1, so he can pass at least 1 cat. So let's take a look at this second sample case. Again, Kefa can only do 1 cat. He can't go to 4, he can't go to 6 or 7, he can only go to 5. So it should be 1, but they're saying it's 2. One, 2, 3, 4. So let's think about this. I see. Okay. So there's 2 cats along the path from 1 to 4. However, the question states they need to be more than n consecutive vertices. So right here, there is 2 cats, but they're not consecutive. It's 1 cat, then a space, then another cat. And so you can go from 1 to 4. You can also go from 1 to 5. All right. So let's get to work on working through the logic for this problem. So we are going to start off with drawing let's draw the bigger tree. So we're going to draw this tree right here. So first we've got one node, then splits into two, then splits into two more. So it's going to look something like this. So we've got this. Now what we're going to want to do is take a look here. So we're going to want to start from this node 1. Now, because in computers we start index at 0, I'm going to call this node 0. This is node 1, this is node 2, this is node 3, this is node 4, 5, and 6. So we're going to start here. We see that this one is going to be red, like they said. This one is red, and this one is red. So what we're going to do is we're going to take a depth first search approach. So if we start here at 0, we can go down this side. And so currently we have one consecutive cat. And that's okay, because it needs to be more than one. Now we hit this vertex, and there are no cats here. So now we have 0 consecutive cats. Then we hit this vertex, there is one consecutive cat. Again, that's okay. We hit this vertex, there are 0 consecutive cats here, so that's good. So we can hit 3 and 4. Now, if we go down this side, there is one consecutive cat, and when we come here, there becomes 2 consecutive cats. Now we know that 2 is more than 1, so what we can do is we can simply just stop. And we don't have to go any further because we know we've already hit more than one consecutive cat. So the answer would be 2. And that's basically how we're going to go. So the path that our computer followed was it basically went down, it found a node, it sent one thread here, one thread there. So it went like this, down like this, and then traced back up, it went here and it went back. So a standard depth first search approach. And just the certain things we will need. We'll need a cats array. We're going to need a, let me move this. We're going to need a cats array. So we're going to need, and this is the cats array will just hold where the cats are. So cats array. So it's going to be an integer array. Actually, no, we can make this a Boolean array. And then we need a visited array because, as for all DFS searches, we do need a visited array. We need an adjacency 2D array. For us, this is going to be an array list array. And the final thing that we're going to need is our DFS algorithm. So the DFS algorithm is going to look something like this. It's going to be DFS. It's going to take in the current node. It's also going to take in the consecutive cats. Now, these two are going to be integers. So the first thing it's going to do is it's going to check if it's cat of node, right? Then it's going to be consecutive plus plus. And then we're going to check if the consecutive is greater than, actually no, we need to check if the consecutive is greater than m, which is our max. Then we can just return. And that's going to be our checking system. And from there, pretty much, that's going to be our DFS. then we just do a standard depth first search, and at the end we will just quickly check if we're at a leaf node, and if we are at a leaf node, then we can simply add 1 to our final answer. That's going to be how we're going to approach this. So it's a simple DFS that just iterates through. We keep track of the consecutive cats, and no, one more thing. If it's not cat of node, then you want to set consecutive equals 0. So that's something that's also important. All right, let's start coding this. All right, so got an empty 580C class, and we're going to start off the way we always do, which is a public static void main, which is going to throw an IO exception. And then we're going to want to set up a buffered reader. Is a new buffered reader of new input stream reader of system.in. And then we're going to want to create a string tokenizer as a new string tokenizer of f.readline. We're going to say that the int n is going to equal integer.parseInt of st.nextToken, and int m is going to also equal integer.parseInt of st.nextToken. Now, next thing we're going to do is create our public variables. We need a public Boolean array called cat. We need a public, and static. These also need to be static. Then we need a public static Boolean array called visited. And finally, we need a public static array list of integers array called adjacency. So now we have these set up. We can initialize them. So cat is equal to new Boolean array of size n. Size n. And visited is equal to new Boolean array of size n. And array adjacent is also a new array list array of size n. And one thing I realized is we also need to make our m value public static int m. We can just do that. So next we're going to want to iterate over n, and this is going to give us our cats array. Cats of I is equal to, string next is equal to st.nextToken. Cats of I is equal to next dot equals of 1 is going to be true, otherwise false. And seems that IntelliJ has a better way for us to do this. Yes, it does, of course. That would have been much simpler. And in fact, we can then just get rid of this and do that. And so now we have our cats array pretty much fully done. We can start up our adjacency array too. We can do that in here. Adjacency of I is going to equal a new array list. So next we're going to want to iterate n-1 times, and we're going to want to say st is new string tokenizer of f.readLine, and then we're going to get two integers x and y. So int x is going to equal integer.parseInt of st.nextToken. Wait. Yes. So since there is a maximum of n vertices and n is less than 10 to the power of 5, we can stick with integers. I was just checking one thing. So int y equals integer dot parseInt of st.nextToken. And so then we're just going to want to say adjacency of x dot add y and adjacency of y dot add of x. And finally, we just want to start off. We want to put a public static int ans equals 0, and we just want to say we want to create our DFS function now. So public static void DFS, giving us an int node and an int consecutive. And so if cats of node consecutive plus plus, and apparently it has a better way to do that. Okay, and else consecutive equals 0. Now if consecutive is greater than m turn, and that's just going to take care of, hey, is too large, we can return. So now we want to create a boolean is leaf equals false equals true, and then we're going to iterate for int I next in adjacency of node. If it's not visited, then we want to DFS next cons, and we also want to say is leaf is false. Finally, if it is leaf, answer plus plus. And that's going to be our DFS function. So then we're going to want to start off with DFS of node 0, 0. And the final thing is to make sure that we subtract 1 from each of these values, because we start at 0 index. And so this should update our answer correctly, and we can just print it out. So now we're ready to actually run this. So we can cd into source, and we can compile. So Java C, CF580C, Java, and then we can Java this. So I'll take the first test case, and it says 2. The correct answer is 2. I'll take the second test case. Again, the correct answer is 2. It outputted 2. I'm going to slightly edit this, by which I mean the second test case. I'm going to. Oh, you can't. So what I'm going to do here is actually, yeah, no. So it seems to have worked well. So we can actually submit it now. So let's go here, and we can start to submit it. So let me choose a file, and Okay, so the file has been chosen, and let's submit it, and we'll see how it goes. Alright, and boom, it's accepted. So Kefa in the park is finally completed, and just some statistics here. If we click on the submission, we can see it ran in 389 milliseconds. It used this much kilobytes, which is not that much relatively, and yeah, it was actually pretty good. So that has, let me just go back to the problem here. That has been Kefa and the park. This is the walkthrough for this problem. If you do want to see my code one more time, I'll show it on the screen. I just wanted to say that I did start a GitHub repository full of Codeforce's solutions. So let me quickly show you guys that, and in the meanwhile, you can take a look at this solution. So here is the main section. And here is the simple DFS. Alright, so here is the GitHub. You guys can just go to this link right here. It contains all of my code. I'll be uploading this problem also into this GitHub repository. If you did want a solution for any of them, you can just take a look through. Some of these I will have walkthroughs, so you guys can check it out. If you are coming from a walkthrough, it's definitely in here. But not all of these problems do have walkthroughs associated with them. So yeah, that's pretty much it for this video, and I will catch you guys in another one. Bye.